Hello, everyone. Welcome to today's workshop, Google Cloud Dev Day. My name is Diogo, and I'll be your moderator. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in the lower right corner of your console. After today's workshop, you will receive an email with a recording. If you wish to contact us, please email us at team@singlestore.com. Mark, now you have the floor.
Thank you so much. Thank you so much for that introduction. Everybody, my name is Mark Lockbeeler. I'm from SingleStore, and I will be one of your instructors today. I am joined by a couple of partners. Shay from Google will be helping us midway through, and Bruce from Looker will also be presenting to you today. So you've got one heck of a lineup. We're going to walk through some logistics here. We're going to be focused on operationalizing analytics and machine learning with Google, SingleStore, and Looker. And what we're going to do today is we do have a 3-hour hands-on session for you. We're going to have an intro. We'll go through that relatively quickly. But we're going to always be here for you if you want to dive deeper on any of the introduction topics. We're going to then do some hands-on prep. We call that the workshop prep section. We'll take a quick break, and then we're going to go through the build phase of this hands-on. We'll be deploying a database for the usage case, which we'll talk about in a second. Real-time database and pipelines. We'll be working with Google Cloud Storage, PubSub, and Dataflow. You'll get hands-on experience with that, moving data, bringing data in and consuming that, and then we'll bring that into SingleStore, and we'll even show you how to do real-time analytics with our extensible stored procedures. And then we'll finish the last hour with Looker and incredible visualization for this build that we're working on today. And we'll help you with a little cleanup. You're going to be using SingleStore fully managed service. You're going to jump inside the Google console and use a lot of services there. And you're also going to get to use a Looker fully managed service. You know, what we recommend from our teaching format today is that we will lecture, then we'll demonstrate, and then we recommend you attempt the hands-on. And that definitely will increase your success rate with the hands-on. But keep in mind, if you need to finish afterward, that's not a problem. We'll keep the SingleStore and Looker fully managed services up on our side, and you'll be creating your own SingleStore fully managed service, but we also have a classroom one that'll stay up for a whole week. You should be able to do a lot. You'll get credits. We'll get you some credits on GCP, so you don't have to pay for this exercise even well beyond today. So that'll be exciting. We'll get that to you. And we hope you gain some incredibly valuable knowledge today. Let me go a little bit further here. We're going to use questions today. So if you have a question for someone, one of your instructors, or you can send it to Shay or Bruce or myself. You want to send it to all of us, that's fine. We'll be using that. Don't use the chat. We'll just use the questions today. And also, we do have a spreadsheet, an spreadsheet that you'll be able to get your Looker login and password from for today. So that'll be very, very useful in the last hour of this session. Now, let's jump into the introduction. And again, I will probably go a little fast here because we really want to get to the hands-on. But we want to share with you a little bit about SingleStore and our awesome story with Looker and Google. And so here, so Google Cloud. So here, what we're seeing in the market, the data is just exploding. Volumes, complexity, Everyone wants to inject AI and ML and add real time to their historical workloads, and the business demands are super high. And we know that the legacy databases and a lot of the systems out there are struggling to meet SLAs. The costs are going through the roof. And just as an example, concurrency for customer facing or internet facing apps is going through the roof. So with that said, we have folks adopting SingleStore. We are a modern RDBMS, cloud native, built for speed and scale. They're using us to build these modern new apps that, as an example, may need to be customer or internet facing at scale with real-time millisecond response requirements. They're augmenting existing systems because those systems are not able to meet the real-time analytic SLAs or even the workloads that combine real-time with historical analytics and querying. And they're also modernizing. Now, at the heart, we're a cloud native. SingleStore is a cloud native database built for speed, scale, and agility. And on the speed side, it's all about speed of query and speed of ingest. Ingest being more than inserts, we're also talking about upserts. So if you think Uber as an example, and you think surge pricing, that's an excellent usage case where we're doing high-speed ingest of real-time data, and we're actually powering the analytics for that usage case. Verizon 5G is another example of a massive at scale. So we'll go to the second value prop here. We're at scale for not only workloads and data volumes, but also concurrency. And we're going to give you an incredibly agile platform, i.e. we run and support ANSI SQL compliance. So a lot of the NoSQLs out there, the Mongos, the Cassandras, the HBases, they do a real good job for purpose built, but they're not very agile and they're not very modern with having ANSI SQL on top. So we're all about speed, scale, and agility. We're absolutely able to do operational and historical analytics in the same engine. So we can do transactions, we can do crazy fast lookups, high concurrency, and we can also do warehouse. We'll work with small, medium, and large workloads, simple, moderately complex, and then the hardest problems out there on the planet. So we're scaling very nicely. We're a unified database, and so you want to think of SingleStore as the database for the future to help with your digital transformation projects. And we are simplifying and consolidating the data landscape. Now, here's some tenets. The ultra fast ingest, and that's very parallel high scale ingest. So trillions of events per second. Blazing fast query. We do a lot of millisecond response, under 20 millisecond, under 10 millisecond. And we do a lot of high concurrency, all leading to very fast analytics. So this is just an example of SingleStore helping to accelerate a dashboard application to 10 times faster, helping to reduce an ETL process 20 times the speed. So we're able to process petabytes of data and do it at a significantly faster performance. And of course, the third example is just the cost factor of possibly augmenting, complementing, and replacing workloads that might be using legacy, appliance, mainframe, etc. So those are some examples of fast, in real time, and at a lower cost. These are why our customers are using SingleStore. So really, it's about transactions and analytics in the same system. It's about speed and scale. It's about batch and real time. And it's about combining a NoSQL capability with a standard SQL capability in the same engine. So these are some of the tenets that we talk about regularly, and some of the horizontal usage cases that we support are ML-driven analytics, operational BI, and any kind of real-time decisioning, customer experience analytics, clickstream, cyber, customer service, doing things in real time. Also marrying it with the historical data. So we talk a lot about IoT and being the ideal engine underneath usage cases like predictive maintenance, like connected vehicles, and like smart city. You all have this deck, so you will be able to click on the links to watch more about how we're powering IoT usage cases. This is an example that we did want to share where we helped with COVID workload over in Thailand with True Digital. And so we were able to track COVID-19 cases. Basically, we were able to establish and track 30 million mobile subscribers. So this uses a lot of our geo capability. We had to process 500,000 anonymous location events every second over 30 million mobile phones. And we did this on Google with SingleStore. And so this is a nice blog that you can look at with a lot more detail around how we deployed SingleStore to support this incredibly important usage case on Google Cloud. We're very, very excited about it. Read the blog or catch up with our team for more information there. We want to point out that we're hybrid. We can run anywhere. We're Linux at the core. We can easily be consumed by your favorite BI or machine learning or favorite language or ad hoc tool. We're MySQL and or MariaDB wire compatible. That doesn't mean the engine has anything to do with those engines, but we do support any client that's built, and most every client is built for those wire compatibility. We believe in bringing data in, whether it's change data capture off of systems of record systems, watching their logs, moving any updates into SingleStore, whether it's streaming with our pipeline, which you'll get to use today, or batch. So we are cloud native. We run Kube, Docker Kube, we'll run virtualized, and we'll also run on-prem. Today, you're going to be able to use our fully managed service. We're real excited about that. So you'll hear a lot more about the fully managed service in just a minute, but you will absolutely be able to use that. And we like to talk about SingleStore complementing Google Cloud services like Cloud Spanner, like BigQuery. We've got customers using SingleStore as an operational DB for real-time, meeting real-time SLAs for mobile, internet-facing, and customer-facing workload, and all the data is going into SingleStore for real-time and also into BigQuery as an example for long-term historical analytics. So it's a really, really nice complement. We also can pull from Spanner off of the OLTP logs with change data capture and bring that right into SingleStore and make that data available in real time, and with historical with BigQuery for the usage cases for analytics and decisioning. So we do complement and you leverage AI, cloud storage, the traditional pub sub and compute engine. We're very, very excited about our partnership with Google. This is just a slide that shows SingleStore working in the Google ecosystem, also with one of our most exciting partners, Looker, to be able to do visualization and BI, to do ML and AI. We've got many deployment options, self-managed on Kubernetes, or fully managed. So we're real excited about all of this. So we'll not go over every component on every slide, but the idea is that we are partnering closely and well integrated and excited about our Google partnership. So let's talk about what we're going to build today. So today, we need to start with, well, why would we care about operationalizing machine learning models? Why does that matter, and what does that mean? Well, what that means is, because the model is not of value until you inject the model into your operation. Usage cases like predictive maintenance, where we're doing anomaly detection, cross-sell, upsell, personalization, and improving customer service. These are all examples of where we want to inject ML into a process. Today we'll inject this into. We'll be showing you how we can bring data in both streaming and batch. We'll also be talking a little bit about how we can inject and extend SingleStore, and also any ML AI can consume the data that we're putting in for anomaly as an example. Now, what we're going to do is we're going to use the New York City taxicab public data. We're going to build a real-time dashboard. We're going to do that with SingleStore as that de facto always-on modern database supporting analytics with an SLA. So we're going to be doing something similar to what you see here. We're going to have live streaming data coming into PubSub. We'll consume also data from cloud storage, and we'll use data flow to pull that data off of PubSub and move it into Google Cloud storage. And then we'll consume that with SingleStore pipelines, and we'll visualize and work in the BI component with Looker. So this is just a high-level topology of what we're going to be working with today. So I'd like to stop there and have Shay say a few words about Google and the partnership with SingleStore, and then he'll be able to present to you shortly on Google Cloud and give you a great hands-on session. But Shay, if you could introduce yourself, say hello to everyone, and then we'll have Bruce from Looker also introduce himself.
So hey everyone, thank you for joining our Developer Day workshop with SingleStore and Google Cloud. I'm really happy to have all of you here. My name is Shay Chang. I am the customer engineer supporting our partner SingleStore, and our workshop today really takes you hands-on into this exercise where you get to play with Google Cloud services. If you haven't before, you get to experience 3 of our services, Cloud Storage, PubSub, and Dataflow, which is what you see on this slide, and be able to take this data, the streaming data of New York City taxis, into a SingleStore pipeline and then visualize it with Looker. So that's a good segue to our Looker architect, Bruce. Go ahead, Bruce.
Thank you, Shay, and good morning, everybody. Thanks for joining us. A couple hours from now, after you're all experts in SingleStore, it'll be time to take off your database developer hats and assume the role of a data analyst. I'll show you step-by-step how to develop with Looker, and by the end of our time, you'll be able to create the dashboard that Mark will show you on the next slide. And you'll be using the data set that you'll be assembling with Mark and Shay. So have fun learning about SingleStore, and I'll be back with you in a while. Thanks. Back to you, Mark.
Hey, Bruce, great. And I just want to check, Shay and Bruce, can you see the dashboard? I'm hoping it's sharing.
Yes, I see the slide. Yep.
Okay, great. 'Cause, so folks, you'll get hands-on with, my fault. You'll get hands-on with the dashboard. Prior to that, you'll get a lot of hands-on on Google Cloud. So not only will you get to try to work with your own dashboard, but we've also got access for you to a completed version of this very dashboard. So we've built one for you to look at as well. So that's going to be very exciting. So let's keep moving because we got a lot to do. It is time to kind of get into the workshop prep. So what I want everyone to do is we're going, and we'll show you where this is, but in your go-to webinar and also in the GitHub, we're going to show we've got a student guide, and that'll in the student guide section A will be prepping, and then in section B of the student guide will be building. So this is the section A of the student guide, and so you should have both this deck that we're going through, the presentation deck, and the student guide, and you can download them from the handouts in the GoToWebinar, or you can download them in a second from the GitHub. We'll be consuming on Google Cloud data flow, PubSub, cloud storage, and we'll be using the Cloud Shell here in just a second. We need to go through this list of prep. So there's 5 steps for prep. It'll go relatively quickly, and then we'll jump into the build phase, okay? So we'll take a quick break for 5 minutes once we get through these 5 items, and then what we'll do is and that'll give people a chance to get some more coffee or whatever your favorite beverage is, from water to sodas, and then we'll be able to get back in it and start working on the build. So the first thing is the presentation deck and the student guide. So this is the GitHub that we will be using today. And if you notice, I've got a screenshot of it, that we do have a presentation deck and a hands-on student guide. We don't have an FAQ. We have the first 2 in there, and it's in the README. And both of these documents are also in your handout. So please download those to your machine and have those available. You'll get a lot of step-by-step in the student guide, and you'll get a lot of overview in the presentation deck. So go ahead and download those to your machine, and then we can just move on, and we'll keep moving here. We're going to go into obtaining your Google Cloud Platform Console. We'll log in there, and we'll show you how to get your credits. So I've already logged into the Google Cloud Console. So if I can show that, basically, if I go to my home page, I'm logged in here, but you should be able to get to the Google Cloud homepage, and we're going to actually walk you through how to. So that's console.cloud.google.com, and then Shay, if you want to talk through this slide on how they get their credits, I think, do we also have, yeah. So Shay, do you want to just talk to them real quick about how to get to the credits?
Yeah, absolutely. So if you already are a Google Cloud user, great, that's wonderful. However, what we're going to do here is not use your corporate account, because there may be organizational policies that would require you taking extra steps as part of the lab. So instead, what we're asking you to do is sign in with your personal Google account, right? So if you just use your Gmail address, sign in to this website, gcpcredits.com/SingleStore. And what you want to do then is to access those credits using your, again, personal account. Probably the best way to do this, as mentioned here, is to use an incognito or private browsing session. So that way you don't accidentally log into your corporate account, assuming you're using your work computer here this morning. And after you accept those credits, you just need to head and create a project. So let me know, drop me a line in the questions if you run into any issues here. Thanks.
Okay, perfect. So folks, you can work on that. And at the same time, we want you to also obtain your Looker user ID and password for Bruce's section later. So if you see in the deck, there's an iSheet link. So if you just have the deck open, I believe it's also in the student guide, you can just click on that. And what you'll see is what's going to come up here on the screen. And I'm just going to show you what we need you to do. So if you go into here, just put your name next to an ID that's open, and we can go all the way down here. You can use any of these, but over to the right-hand side, you'll see your login and your password. Now, you won't need this for an hour and a half or so, but put your name in here and go ahead and copy and paste your user ID and password over to your local machine, to maybe a local notepad, okay? And so that's how you're going to get that. And if you have any questions, just please let us know. We'll be happy to help you there. So the next thing we want to do, you can get your credits. I think you could apply your credits at a later time if you want as well. You can get the user ID and password. But I'm gonna walk you through spinning up a SingleStore fully managed cluster right now, okay? And so what I want everyone to do is I want you, this sign up requires you to use an email, and here you can use your company email and password, and you have to go down and click on create an account at the bottom. And it will send you an email. You'll have to validate that. There's no charge or anything like that. But this will get you into the SingleStore portal. You'll see this screen. You'll put your name, first name, last name in. You'll create yourself a password and you'll confirm it. And you want to get to this screen. So this is the screen that I'll need everybody to get to. And I'll demonstrate, I'll walk through the screens now, and then I'll demonstrate what it's going to look like when we spin up this cluster. So go ahead and start working on that, and I'll slowly walk you through spinning up the cluster. So you're going to see something like this. You're going to want, when you hit the Create Cluster button, you're going to call your cluster whatever name you like, and that's just you're going to pick free trial, okay? That cluster will run for a month for you. It's a small, and I want you to keep the size at S00. And then what we do, so S00 is the default. We pick Google, we pick S00, and it should say trial, okay? So you should be able to run it for a month. You should have plenty of credits in there, and it'll give you a modest cluster with 16 gigabyte, 256 gigabyte of RAM. There's no charge here. This is a trial cluster for 30 days. If you don't do anything with that, it will go away, etc. So we'll run, you could pick, I picked Virginia North Virginia. That's a good one to pick. Or you can pick whatever whatever your preference is when the drop down comes. And because this is just a development session with very public data, I recommend you just say allow access from anywhere, okay? If you want to set some security where you have to put your IP in, that IP address in, that's fine as well. And I believe it'll actually default and put your local desktop in there. So you can do that, but I always recommend, since it's a simple development workshop with public data, just to use allow access from anywhere. That'll let any of your favorite BI tools and or SQL Workbench, etc. Any SQL client can get to it. So that's what we want to do. and then it'll start deploying for you. So it's going to look like this. Then you should get to this screen. Your cluster has been created successfully. So I'm going to show you this real quick in the portal, and you'll see what that should look like. And then you can obviously try that yourself. Now I'm already logged in, and I've already got a classroom cluster up and running that Bruce is going to allow you to log into with the finished dashboard. But so this is actually for today for the class. But you're also going to create your own cluster. You're going to click on the button on the top right. Mine's going to look a little different than yours, but you do the free trial. So that's the only difference. We're going to pick Google. You'll do free trial, and I'll just say Google Dev Day. And I'll just do that. I'll leave it at S3 sizing, and I'll hit next. And then I'm going to put a password in, a secure password. You can let it generate one for you, but this password you need to remember. This password is going to be how you log into the SingleStore cluster and create your databases. So you'll log in with the admin ID, ADMIN, user, and whatever this password is. Again, I'm going to allow access from anywhere, and I'm going to actually have this expire after 4 hours, but your free trial will last for 30 days. So I'll hit create, and this is the screen where it's going to go from 0 to 100. And when that's done, the cluster will be available to you. Now there's only one more prep step. I'll do that, and then I'll come right back to this. The only other prep step that we have today, by the way, we'll come back and I'll show you how to grab the connectivity string, and we'll connect up with the cluster from the Cloud Shell. But let's bring up the Cloud Shell real quick first. So that's the last thing we want to do, is bring up the Cloud Shell, download a GitHub, so all the code's local to the Cloud Shell, and then we're going to connect to the SingleStore endpoint. So let's give that a run real fast. In the Cloud Shell, so I'm going to launch the Cloud Shell from the Google Cloud Platform console. I hit the little button up on the top right. That's an arrow with an underscore, and you can see it's provisioning a Cloud Shell for me. The cool thing about the Cloud Shell is it already has Git installed. It already has the client, MySQL client, which is compatible with SingleStore, already installed. So that's a nice little environment that we can work from to connect to the cluster that we're actually spinning up. So this is spinning up here, and I've got my Cloud Shell. If I just do ls, you can see I don't really have anything in there but a README. It's kind of a nice little Linux shell. If I go back to the cluster, it's about 70% done. So let's let this finish up. And while that's finishing up, let's go ahead and pull the GitHub. So if you go to your student guide and you go down to the section we're on, we're towards the end of the prep, and that is going to be down here. I'm on page, I'm scrolling through. You can see where we are here, right beyond the Cloud Shell. I'm just going to copy this get clone command, and I'm going to go over to my Cloud Shell, and I'm going to run that. I'm just going to copy and paste it, and it's going to bring down the GitHub, all the code we need for today, and it's just going to drop it into my Cloud Shell. So now if I do ls, I can see that I've got a directory called SingleStore GCP Looker Dev Day 01, and I'll just cd into that. And now if I look in here, I've got section B, which I'll just change directory to section B. And you can see that I've got all my code in here. So this is a good thing. I'm able to easily bring down the GitHub to the Cloud Shell. And we'll take a look at this code. But we'll be using, let's go back to our SingleStore real quick. So it's 91%. Hopefully, you've been able to get your cluster rolling and your cluster's almost ready. What I'm going to do when it gets to 100% is I'm going to click on the button up here on the right. It's grayed out right now, but it's going to be my connection string to my cluster. Now, we also have a really nice visual tool called SingleStore Studio for monitoring. It has a basic editor in it. You can think of it as a SQL client to SingleStore with a nice UI. And we'll take a look at that, and you can leverage that today too. And we'll also be doing work from the command line. So I do need to wait for this to finish up so that I can connect in. I hope everyone's able to get through, get their Cloud Shell spun up, get the GitHub downloaded, and if we could just wait for this to finish up, we'll be in good shape. What I wanted to do is I want to walk through, while I'm trying to get help there, I'm going to walk through the create step, so step 1 of the build, and we'll come back to the hands-on here in a second. So the next step that we're looking at is creating the database. Really, it's all around New York City taxi schema. So what we're going to basically do today, and I'll go back and show you real quick on one of our diagrams. I'm going to move back in the deck and just show off this again a little slower. We're basically going to be bringing in, we've got real-time driver data and real-time rider or trips data. So we've got trips events coming in, and we've got driver events. And Shay's going to go through all that with you in detail, and he'll talk, and we'll also be consuming neighborhood info. What I need to do though is set the database up so that as we start to go through step 2 and 3, we'll be able to consume that data through these pipelines and through this workflow. And of course, then Bruce will be able to visualize that, and you'll be able to work with it from a looker perspective. So if I go back to the build step, what I wanted to show you is the actual code that we're going to use to create the cluster, and then also the code we're going to use to create the stored procedure. So let me just go to the GitHub real quick and just show that off from the GitHub. If you notice, we have in section B, we have a create New York City taxi tables DDL, data definition language. And if you notice here, we're going to create the drivers table. It's going to be leveraging some of our geo capability. The neighborhoods table is actually going to be using each neighborhood or borough, and you'll see this in a little bit, is a polygon. So our every borough in Manhattan and New York City area is represented by a polygon. I think there's 307 of them, and they'll move into the neighborhoods table. And then the trips, we're actually going to have a trips table. So this would be the ridership. So we've got drivers, we've got trips, and we've got neighborhoods. And then we've got some stat tables for some of real-time stats that we will create. They're just simple tables that we're creating, and our stored procedure will populate them. And then we've got a couple other tables that we will build. Now, I want to show you also the stored procedure that we're going to be working with, and just give you an idea. And that's also in section B. If you can see, create derived stats. Now, this is just a simple example of using our extensibility language. And here we're going to create a procedure called derived stats. We're going to do some cleanup work in the declarative section of this to make sure that every time we start this, we make sure that we delete all the values in the statistics tables, and then we add a value of 0 as a starting point. But the real logic behind this, and I'll try to make it bigger so you can see it, is that we're going to just, for the demo, for your build, we're going to loop through and we're going to run a number of analytic queries. This first one, as an example, is the total number of trips for each neighborhood. And you can see that we're basically running an insert, but we need to select from trips and neighborhoods. We need to do a number of things here with geo intersects, etc. But basically, we could pick up the total number of trips. The second one is the average amount of time between someone requesting a ride and that person being picked up. The next one is the average distance of each trip, etc. So we've got about 7 queries that we're running consistently, and we're looping through and we're sleeping, and then we run it again, and then we sleep and we run it again. So as data is getting consumed in real time into SingleStore, based on, I think we let it run every 3 seconds. We'll have a script to start this. But these are the 2 build steps we want to do to get the environment ready for the remainder of the steps.
What I'm going to do next is to take you all through the next section, which is setting up your Google Cloud services for this lab. So let me go ahead, Mark, and take control. And hopefully everyone got a chance to be able to set up your Google Cloud credits. And what you should be able to see is that you should be able to see $50 in credits in your account. So again, if you didn't already go through this process, if you go to gcpcredits.com/SingleStore and click sign in, what you would be able to see is that you'll have a coupon code that's automatically populated here. And again, you want to do this on your personal account so that you don't have any organizational policies if you're a corporate Google Cloud customer that could interfere with our lab. A lot of it is just around security, and you'll have to go ahead and do a few extra steps to get around those, which I can help you. So just drop me a note if you run into that. And after you click through that first page, what you should see here, right, on the billing overview for that account. So you'll see that there's a billing account here that's called Google Cloud Platform Trial Billing. And on the right-hand side, what you'll see is that you have $50 of credits for this lab. And just as a reminder, at the end of this workshop, you do want to turn down, at a minimum, the data flow service, because that is going to be the bulk of the costs from the different services we're turning on from the Google Cloud perspective, so that you don't get charged. So you should see $50. They expire in 3 months in September. And this should more than suffice for today, and also a few more days if you want to play around and keep those services running. So what I'm going to talk about here is setting up these various services. So let's go ahead and recap just this slide, right? Because it's a good reminder of what we're doing here. So we have this New York City taxi data, and there's 3 components to this data. 2 of them are streaming components. So you have the drivers and the trips data. So the drivers is effectively a streaming data source that has different drivers' names, their locations, and then trips, pretty self-explanatory, where it is also streaming and maps out the coordinates for a ride. So both of these are streaming sources that will be ingested into the pub subservice. And then as you can see here in the bottom, there's also a third static data, a piece of data component, which is the neighborhoods data. And this is just a polygon array for New York City boroughs and different neighborhoods within the 5 boroughs of New York City. And that would just be copied over into your cloud storage bucket. So what I'm going to take you in the next half hour or so is a brief explanation if there are folks who are new to Google Cloud about what these services do. So most notably, what is cloud storage, right? What is PubSub? What is data flow? And then we'll also go ahead and set up these 3 different components, and I'll show you what you need to do as part of the lab here prior to ingesting the data into the SingleStore pipeline. All right, so first a little bit about cloud storage and where it sits within the portfolio of Google's managed data services. Right, so you can see here that within Google, there's a lot of different options for storing your data. This is just a subset of some of them. So from the far left, you have your Redis and in-memory types of data storage, all the way through non-relational databases like Firestore and Bigtable, the relational databases like Cloud SQL and Spanner. And cloud storage is really your object store, right? So what is object store if you're not familiar with that term? Object is just a piece of data, right? It could be a text file, it could be an image, it could be a sound file, and it's basically being stored into a location that's accessed by a URI, so Universal Resource Locator. And typically it's contained in a bucket, right? So a bucket is just a container for your objects. And what you can do is you have a lot of flexibility in choosing both the location and the storage class for this service, for an object storage service. In other words, your location, right? You can choose where it's located around the world, whether you want it in a region like US West 1 or multi-region in different regions in the US. And the storage class allows your objects to be stored and served with different access frequencies, as well as availability levels and pricing profiles. So maybe it's data that you need to access every day, or maybe it's just archival data for that you're keeping around for auditing purposes, right? So depending on how often you need to access that data and retrieve it, it may or may not make sense to keep it in a hot storage like multi-regional, and you may want to move that to something like nearline or code line storage, and not only be able to pay less, right, but also keep it there, and also we'll talk about in a sec things like lifecycle management and retention policies. So what differentiates cloud storage, right? So cloud storage is not just an object storage service similar to S3, it's also very reliable, simple, and secure. So it has a unified experience. And what this means is that there's a single API and consistent performance across the storage classes, regardless of the level of hotness or coldness of that data. It's also strongly consistent. So what that means is it guarantees that the listings are always up to date, right? And that helps you because it simplifies things like developing your applications. There's no stale or inconsistency when you're accessing that data. In addition, I mentioned multi-regional, and what that does is it makes it geo-redundant, right? So we're talking about 4 nines of availability. A lot of that can be automated, so there's not anything you have to do in terms of having a separate replication engine to replicate your data, say from US West to US Central or US East. All of that is automated for you. And it's also highly scalable. So this is actually the same infrastructure that we here at Google use for our own needs. That's already built, of course, to extreme scale to handle the applications that we have that have multi-billion users. and then it will help you and your customers can scale to as high as you need. So these are the 4 different storage classes that we have with Google Cloud Storage. And you can see here, right, depending on your use case, your application, we're going to move from the left multi-regional all the way to the least access data in code line. And for the purposes of this lab, what we're going to do is just set up a simple bucket that's going to be a multi-regional bucket in the US. There are ways to set up things like object lifecycle management, right? So for instance, if you have a bucket or data that is sitting in a multi-regional bucket and it's not being accessed, right? What you can do is have a policy that says, okay, this data is not being accessed within a month, within 3 months or a year, move it to nearline or cold line automatically, right? And there's also retention policies where potentially, after moving it to, say, cold line and archival storage, you don't need to keep the data, but after a certain number of years, but you still need to for the first 5 years for auditing purposes. Then the retention policies can be set up so that once the 5 years have been met, that data gets deleted automatically without any manual intervention from an administrator. So those are all things you can set up within Google Cloud Storage. A lot of that is outside the scope of this lab, but I do want to point out the various things and features that are part of the Google Cloud Storage service. So I'm just going to take a quick pause here, see if there are any questions. Okay, doesn't look like it. Again, if you have any questions, just drop that into the questions here in the GoToWebinar. So next, I'm going to talk a little bit about the next service that we'll be using out of our trio, which is PubSub, right? And what Google PubSub, so Google Cloud PubSub lets you do is to handle large volumes of streaming data, which is something that we're doing as part of this workshop, right? So those event messages that are streaming in could be from many different sources. It could be 1,000 or 1,000,000 different events coming from all those types of sources, all happening asynchronously. And a common use case where you see this pattern occur is with IoT applications, right? So it could be sensors that are sending out their location data every 30 seconds for every single driver, sort of like this lab that we're doing today. It could be temperature sensors placed throughout a data center to optimize and measure heating and cooling costs. It could be a variety of things. And when we talk about processing streaming data, there are a few challenges, right? So the first is that streaming data from various devices or processes, they may not even talk to each other. And they could send bad data or data that's delayed, right? So you have to take those types of challenges into account. In addition, we need a way of not only knowing and collecting these streaming messages in some sort of buffer, but we also need a way to allow other services to subscribe to new messages that we're publishing out, right? So what this means is that the service needs to handle an arbitrarily high amount of data, so we don't lose any messages coming in. Those messages need to be buffered and it has to be reliable. It needs to be highly available. And we also may need a way to look at all the messages to remove any duplicates if we find any duplicates. And PubSub is exactly this tool that will allow us to handle this distributed message-oriented architecture in a scalable manner. And by the way, if you didn't already know, the name is so named because it's a publisher-subscriber model, right? So the service effectively publishes messages coming into a topic to subscribers, right? So at its core, PubSub is a distributed messaging service that can receive these messages from a variety of different streams. Again, upstream data systems like IoT devices, gaming events, application streams, and more, and then sends it downstream to any subscribers that are listening. So it ensures this at least once delivery of messages and passes them to subscribing applications. And there's no provisioning involved here at all, right? So what this means is you'll see that here in the lab, it's totally serverless. Whether there are a ton of messages or none at all, PubSub will be able to scale to meet that demand. You don't have to do anything yourself. You don't have to configure any servers or manage any virtual machines. All of that is taken care for you by the service. And also the APIs are open. So the service is global by default, and of course offers end-to-end encryption for these messages. I'll give you another analogy. I know most of us are listening to streaming music nowadays, but the analogy here, thinking about the PubSub architecture, the central component is the topic, right? So you can think of the topic in this analogy like a radio antenna. So whether your radio is blasting music or it's turned off, the antenna itself is always there, right? If the music is being broadcast at a frequency that no one's listening to, the streaming music still exists. And similarly, a publisher that is sending data to a topic that no subscriber is there to receive, it's still being sent. And the inverse, where you have a subscriber, it could be listening to hear data from a topic where there isn't any data being sent to the topic. So that's kind of like, I suppose, listening to static, right, if you're on a bad radio frequency. So you can have a fully optional pipeline where your publisher is sending data to your topic and an application is subscribed and pulling data from it. Or you can have one where you may have many publishers and many subscribers. So there's not really any limit, right? You can fan in, fan out. It's completely decoupled, which is what makes this a very good way to scale as well as to decouple and be able to absorb things like spikes, right? So if you think about it, the asynchronous architecture allows your subscribers to catch up gracefully when you have a spike of incoming data being streamed in without having to over provision resources. And I think that's really, probably one of the robust features of PubSub that simplifies systems, right? So that you don't have potentially something that is blocking in a synchronous architecture where every component needs to speak to every other component. Instead, each component only needs to know how to speak to the PubSub system. And that's where PubSub allows you to be able to scale and make your architecture asynchronous with this model. We'll see shortly that there are both push and pull subscriptions. So as part of this lab, we're going with the pull subscription there in the middle. A push subscription, right, is used if, let's say, you have multiple topics for the same webhook, where an event comes in and you want to automatically trigger some sort of downstream process. Whereas a pull subscriber is more typically used where if you have a large volume of messages, which is what we have here. If you think about the streaming data again with both the trips and the drivers, so two separate topics that we'll see shortly. And also if you have, if you want to look at being critical about efficiency and throughput, typically the pull model is used more often. Okay. Going on to our last and third service at Google Cloud that you'll be working with today, and talking about this a little before I show you what this looks like in the Google Cloud console. So this is Cloud Data Flow, right? And Data Flow is a serverless execution service for data processing pipelines written using Apache Beam. So Apache Beam is an open source software, and basically what it does is it supports both batch and streaming workloads. So that's, by the way, where it gets its name, right? Where batch and stream is a portmanteau that together makes Beam. So Apache Beam it allows you to effectively use the same code for both your batch and streaming data ETL workflows. And if your organization or you have data science teams that are working with software like Flink and Spark, this is also where you can potentially run data flow. In this case, running your Beam pipelines in the cloud, right? Being that it's built on Apache Beam, a lot of this means that your pipeline code is portable. And why would you potentially want to use Dataflow? Well, it's the most effective execution environment upon which to run Apache Beam. So the Dataflow team at Google is actively contributing to the open source library for Beam and building features around the latest Beam offerings. If your organization today, if you or your teammates are running things like Hadoop and Spark using another Google Cloud service called Dataproc, well, that's in some ways there's some overlap here. And with Dataflow, the reason why it's serverless and it's easy to use is that you don't have to manage any clusters at all that you do have to with Dataproc, right? So we're not talking about Dataproc, but just if that is something that your organization is using, what you'll see here in that Dataflow has an auto scaling feature, which allows you to scale step by step automatically, and it's also very fine-grained. So I mentioned that it's serverless, which means that there are no servers for you to manage. Although what I'll also show you is that you can, if you wanted to, you can dictate things like the type of machine, the instance type, right? How many resources you want, but you don't have to if you don't want to. You can simply just use a template, which is what we'll do as part of the lab, and you'll still get a lot out of Dataflow. So if you did, right, have a ton of data to process, Dataflow will intelligently call upon more virtual machines to help. That will be able to auto scale up as needed and scale down when streaming data coming in slows. And because it's low latency, this data is processed as soon as it comes in. Okay. So what we'll do here as part of the lab, you can see that Dataflow supports a variety of sources and sinks. The source that we're using as part of our lab today is Cloud PubSub, and then the sink on the right-hand side will be cloud storage. So there could be a variety of not just Google components, but also others, where what we're doing is effectively transforming this data if we needed to. In this case, we're simply taking the data coming in from a public PubSub topic and then ingesting it, saving it to cloud storage into a bucket so that we can then process it using SingleStore. So again, just to show you what we're doing. So we have two PubSub topics that are public that are listed here, as well as in the lab guide, lab manual. And both of these will be part of a Dataflow job where the streaming data that's coming in will be batched and saved to cloud storage. And then we'll also copy over the static neighborhoods file to our cloud storage bucket as well. So this is a sample of what that data looks like. And what we'll do next is let me go ahead and move over to our Cloud Console and share, go through a quick example of what we're going to do with the lab. Okay, so I think I'm sharing my Google Cloud Console now. Yep. So I'll share also a few tips that are just things that I found to be really helpful when using Google Cloud. If you are a current Google Cloud customer and user, you may already know about these things. And if you're not, then these are ways to make it easier when exploring and working on this lab today. So what you'll see here is, first of all, let me move to my cloud storage bucket. And what you see is that I have a lot of the services I use the most pinned to the top, right? And you can simply click on, for instance, one of these pins at the bottom, and then they'll show up here. So let's say, you want to use Marketplace. Well, in this case, Marketplace is one of the ones at the top, but maybe something further down, right? Like monitoring, if I pin this, it then will show up here at the top of my upper left. So your menu is going to look very different from what I be able to access the services we use a lot very quickly. So just to show you the end result of what you'll be doing today for this first section is that you'll have three files, or sorry, these three components, right, in your bucket. You should have the static neighborhoods TSV file. And just to show you what this looks like, you'll see that it's really just a single file. Let's see if I can. Yes, I'll have to show that screen. So you'll be able to see in the lab, it's basically a tab separated value file where, as we saw here, it has these various polygon shapes for the different neighborhoods in New York. So that file is static, right? Everyone's going to have the same file there. And then what you'll have are two folders, one for drivers with incoming data that's being streamed in, and you'll have a lot more of these, and then one also for trips. So let me go ahead and actually delete both of these folders because I'll take you through the process of setting up the data flow pipeline. In that job, those two jobs are the ones that will be generating the drivers and trips folders here. So what we're going to do is once you have this bucket set up, right? So I'm actually not going to show setting up a bucket, but in the lab guide, you'll see that you'll be setting up a bucket using, in this case, Cloud Shell. So Cloud Shell, if you are new to Google Cloud, is just an interactive command line environment that has the Google Cloud SDKs installed, and it's you can access it just by clicking the little Cloud Shell button here on the upper right. So this button, Activate Cloud Shell. And then what you'll get is this terminal that has, again, the Google Cloud SDKs. So the one that we'll be using is the Google Cloud or the Google Storage utility, so GSUtil. And you can see that if I, for instance, want to list out the different files I have here, let me actually open it up in this window. So what this will do is list out all the objects I have, which currently is this one TSV file, right? And then you can, of course, copy, you can delete, you can change access control list using GSUtil. One tip here is definitely, if you're working in Cloud Shell, take advantage of the Google Cloud Project, a global environment ID, right? So that global environment variable, sorry, is by default the name of your Google Cloud project, right? So in my case, it's SingleStore-lab. In your case, it'll be something different. But what this means that you can very quickly, use this in not just command line, but also within scripts and other automated, commands and APIs, so that you don't have to substitute in if you're using various projects. Okay, so once you have that Google Cloud storage bucket set up, the next service we're going to use is PubSub, right? So the PubSub service here, what we're doing is we have those two public topics running, right? So these two topics have already been set up. They're running out there. So again, going back to that radio station analogy, there's effectively two of these radio stations broadcasting one streaming source of data for drivers, a second streaming source of data for trips. And there may or may not be any listeners or subscribers at this point, right? So to show you what that looks like, what we're going to do is actually go ahead and delete this, recreate this from scratch. Is you're going to set up, just as part of a test, a subscriber, and you're going to say, let me subscribe to the one or both of those public topics, right? So what you'll see here is that we don't have any topics set up in here, right? So if I go back here, there are no topics in my project here because the two public topics are in a different project. So you'll see the exact same thing on your end, where in your project there are no topics. That's fine. We'll create a subscription to the public topic that's in a different project. So what you need to do here is come in and enter your topic manually. So this is all in the student lab manual. And you can also explore some of the options down here, right? So this is where if you were doing something else, you may want to use a push topic instead, where you can have, similar to a webhook, you can have a downstream process run once a message is published to this topic. In our case, we're going to go with a PO type of subscription. You can also specify how long you want to retain the message for, right? By default, it's 1 week. When do they expire? The acknowledgement deadline. This is pretty important, not for the purpose of this lab, but if you already set up something in production, where let's say you have a potential. I'll give you an easy example, right? So like in my home here, I have a bunch of smart devices set up, and I use a push subscription. So my use case is when my smart camera detects that a human is seen at my front door, it sends me a photo, right, to my cell phone. And what happens is if that downstream process does not acknowledge the message being received, right, within, let's say, 10 seconds, then another message gets resent to the subscriber. So this depends on how long your downstream process is going to take, right? If it's going to take more than 10 seconds to retrieve an image from that camera and push it out via a text message, you may want to up this to say 15, 30, whatever your application downstream is doing, right? So the purpose of our lab, you don't actually need to touch any of these. I'm just showing you some of the different features, right? So for our purpose in today's lab, most of these are just advanced features you won't be touching, but there are a lot of cool things you can do with PubSub that aren't immediately like, unless you actually come in here and play around with it or do your lab, you may just not ever know about it. So definitely recommend just with all things, don't just read the lab and go through it step by step. Take a look at what else is part of it, just again, to broaden your horizons since you're here already doing the lab. So we're gonna go ahead and create this topic, or sorry, the subscription to the topic. And what you'll see that is once we have it created, we can go ahead and view the messages, right? And I'm just gonna click on enable ACK messages. You don't necessarily need to do this, but what it does then is that it doesn't pull that message again. So once we do that and pull, what we should see is that we'll have some messages that you see here. And since this is for drivers, you'll see that we have a bunch of driver names, and then you can see where they're located. These are coordinates. And similarly, you can do this for the second topic, which is for trips, right? So I'll skip doing that. I'll leave that as an exercise for you to try out. And then the last part of the Google Cloud hands-on here is we're going to set up a data flow job, right? And just to rehash what we're doing is we're taking the two public PubSub topics and automatically taking that data and then putting it into cloud storage. So if I go back to data flow, we're going to, and one thing I forgot to mention is that you'll need to enable the data flow API, which by default is, I think, not enabled for a new project. So you can just do that by searching at the top here for data flow API. And once you find that, you'll see that there should be enable, and just click that. If it says manage, as it does here, right, then I already have it enabled. So just make sure you have that enabled. Okay, so going back to data flow, let's go ahead and create a job. And what you'll see here is that data flow has a lot of these templates that make it really, really convenient for you to set up a data flow job. So you can, of course, do this via, you can see here, a command line, our REST APIs, or if you're new to all this, in the console using the templates, which will make it very, very simple, sort of like filling out a wizard, you know, a WYSIWYG wizard. So we're going to name it drivers. You'll be creating 2 of these jobs. And for the regional endpoint, right, which region you want this to run, you can just set it up to run in US Central. So the template, right, this is where you can see there's a lot of these templates that are already here, right? So you can see that PubSub is one of the options for the source, like I mentioned, but there are also third-party non-Google sources like Kafka, Hive, you know, files that are on cloud storage. So a bunch of different templates that you can find in here. And then also a variety of syncs too, right? And in our case, we want to choose cloud storage as a sync. So the template that we're going to pick here is, I'm going to filter on storage, is PubSub to a text file on cloud storage. So make sure you pick this one, not the one above. We don't want an Algebra file, we want a text file for the next part of the lab. And then once you pick this template, you'll see that there's a few parameters you need to fill in, okay? So the first parameter here, the topic, is the same topic we just used for our subscriber. So this is that public topic that we have for the driver's data. And then the output file, right? So what this is the output where you want to save into your cloud storage bucket. So depending on your name of your cloud storage bucket, you just replace that in the brackets here. Mine is SingleStore Lab. Yours could be something entirely different. And then the prefix, so we just have this as drivers dash, and then the temporary location, and we just have this called this temp. So once I have this set up, I'm gonna go ahead and run this job. And what you'll then see here is that this job will start to load, right? So this will take a few minutes. Just be a little patient here when you run this. And one thing you'll want to inspect is that no warnings or errors show up, right? So at this point, it's already apparent that things are starting to run. If I have a little yellow or red little icon here on the bottom next to the logs, that would indicate something may be wrong. So definitely look into that, because if you have a warning or an error, your data flow job will not run and you will not be able to process this streaming data. So just take that into account. And what you also notice here while this starts up is that there's a bunch of things, information that you see on the right-hand side, right? So some things I want to point out, you know, where is this running? US Central 1F in that zone. There's a worker, right? And I'll show you what that looks like. How much resources are being used. This will, of course, go up from these zeros in a moment. And then also the different pipeline options here, right? So our max number of workers by default is 3. And what you'll see here is we should have at least 1, if not 2, running shortly. So if you also click on some of these metrics later, it's not really interesting right now because it just started up. But shortly, what we'll see here is that there'll be a graph of how many elements are being processed in each of these stages. And you can see here what we're doing is we're reading in these PubSub events, and we're taking a 5-minute window. Then we're writing that file to cloud storage. So this is all adjustable, right? But this is the default data flow template that we're using for PubSub as a source and cloud storage as a sink. And what the 5-minute window here means is that it will be 5 minutes before, if I go back to my cloud storage bucket, before any files show up, right? So you'll need to be a little patient, wait a little more than 5 minutes before that first file shows up in a newly created drivers folder. In the meantime, what I'll also show you is that if we take a look at compute engine, right? So if you go to compute engine on the navigation menu here on the left, or if you just want to search for it, right, by typing in compute engine at the top and launching that page, what you'll see is that what's going on is we're actually starting a VM instance. So this VM instance is named drivers dash, and it's located in that US Central 1 zone. And this is something that was done under the hood automatically, right? So you didn't have to do this. It's fully managed, meaning the data flow service started this one worker to allocate to the job of processing incoming streaming data. And you know, it's already set up here for you, but you can see that there is a VM instance that's running. And furthermore, what you'll do as part of the lab is you actually set up a second job. So let me do that right now and call it trips. So you'll need to replace a few things. You can either, what I just did here, and just go back one step, is I clicked on the clone button at the top while I'm on the driver's job, assuming you didn't get any warnings or errors. If you wanted to, you can of course go back and just create a second job from scratch, but using the clone feature makes it a little easier, so I don't have to fill out everything, right? So I'm just going to replace everywhere where it says drivers with trips. So in this case, same template, pub sub to cloud storage, reading from a second public topic, and then saving it to my bucket in a different folder called trips, and also using a different output prefix name just for myself. But before I click create, what you'll notice here at the top, at the bottom, is that there's a bunch of these advanced options, right? So what you'll see is that if you wanted to, you can specify a lot of other things. For instance, how many workers, if you want to scale up beyond 3, for the purpose of this project, you wouldn't need more than 1 or 2. And then also, if you wanted to change things like the machine type, right? So by default, it uses the N1 standard 1 machine type, and we can verify that here by clicking on the VM instance. So this is a virtual machine that has 1 CPU, but if you, my mistake, it's M1 standard 4. But if you wanted to, maybe you wanted to go with something bigger, right? With more memory, with more compute CPUs, you can certainly do that. If you want to change it from the default M1 standard 4, you can put that in here. So even though it's serverless service data flow, you do have a lot of control over some of these parameters here, right? As well as network allocation. So we won't be touching these parameters as part of the lab, but just showing you that these are options here that are available for you to tweak if you needed to. Okay, so once you create that second job and we click on the view details, you'll see that it should also, you don't want to see any errors or warnings. If you do, definitely inspect that error message and drop me a question if you need some help resolving a potential warning or error. And soon, right, within a few minutes, you should see, similar to the drivers, looks like we already have some data in here, right? How many elements added? 594,000 already. And you can see that so far it seems like just been 1 5-minute window. But after a while, you'll see that there's a graph of the throughput elements per second, and then also outputting this, of course, to cloud storage. So if we go back to cloud storage and we refresh our bucket, there it is. We have that 1 drivers folder, and we have 1 file, right? And what you see here is that in another 5 minutes, right, at 10:45 or 10:50, we should see another, Pacific time, of course, we should see another file. And those are the files that will be ingested into the next part, into the SingleStore pipeline. And also a second folder, trips, will be created shortly as well once the second data flow job ramps up and starts processing data. Yeah, so that's pretty much it for the Google Cloud Services section of the lab. Take a look at the lab guide, and one thing to note again is you want to, at the end of the lab today, to go to your data flow. Make sure your data flow jobs, you want to stop them, right? So what I mean by that is make sure they're not running, because otherwise you will be charged. And the $50 will last you beyond today, but you don't want to keep this running for, say, a week or a month continuously if you're not using it. So when you're done with the lab, just make sure you stop the job. Either cancel or drain. Either of these options would work. All right, so I think we'll give folks a few minutes to go through the lab guide and run through the instructions. Hopefully they're pretty simple. And drop me a question if you run into anything. Oh, sorry, one last thing is for the next part of the lab, right? Once you have the data in here, your neighborhoods, static file, and the 2 drivers and trips folders, what you'll need to do then is to set up what's called an HMAC key. So these are the credentials for SingleStore to access this cloud storage bucket. So you can do that by going into the cloud storage settings here in the console, and then just creating a key, right? So at the bottom here, user account HMAC, go ahead and create a key. And you'll copy both this access key and the secret. And those will be used in the next step, where we'll be ingesting the cloud storage data into the SingleStore pipeline. Okay, so I'm going to stop talking, give you guys a few minutes to work on that, and hand it over to Bruce back to Mark in a few moments.
Yeah, no problem. We'll let everybody work on this till like 2. Let's say we'll give everybody like 10 minutes if they want to take a break or whatever, and we'll start back at 2 o'clock even. And give us feedback in the questions if you're actually having any problems. Just share with us on there, and we could help you out. So looking forward to that, and we'll start back in 10 minutes. Hey everybody, it's Mark again. Just wanted to remind you that we're going to be coming up on the Looker section, and we'll want you to go ahead and get your login. So if you go back to the preparation section in this deck, all you have to do is click on this iSheet, and you can go ahead and add your name in and grab your Looker ID and password so you can log into the Looker fully managed service. So I wanted to just remind everybody of that. I'm actually going to walk you through from the Cloud Shell. I'll go back and do step 1, and then we'll do step 3 real quick. And so let's go ahead and do that real fast. I'll bring you back to the student guide. We've moved into the correct directory here, and I'm going to log in. If you take a look in the student guide, section B at the beginning, step 1, what we do is we ask you to grab this connection string from your cluster. It'll be in the portal. There's a connect button on the top right, and if you grab that and go over to your Cloud Shell, you'll be able to connect to the SingleStore cluster. It'll look something similar to what I'm showing here. And basically, I'm connecting into my GCP cluster that I just spun up with the admin user, which is part of that string. But you do have to type your password in here at the end. So when I connect in, I'm into SingleStore, and here I can say show databases, and you'll see I already have a New York City taxi that Bruce and you guys will be using in a minute. But I'll still simulate this. What you want to do is you just want to run this statement here: source, create New York City taxi table. So just go ahead and copy that. But remember, you have to log in not only to the Cloud Shell, but you also have to be in the right directory. That is the section B directory. And then you have to use the MySQL command line to get into the cluster like I just did. Then you can run to create your tables, and then you can run show tables to see that all the tables are there. And so that's a pretty straightforward process. So if I say use New York City taxi, so I'm inside the database, and then I just say show tables because I've already run the other command. You can see we've got all the tables we need for today's session. Now, if we go in here and we create the derived stats SQL stored procedure, you just have to copy that and it'll create that stored procedure for you. I've already got that done. Now we went through step 2, and thank you, Shay, for doing that for us. So let's switch over to step 3. Now, step 3, you're gonna have to do a little bit of editing, and I'm gonna show you this. So if you're in your student guide, if you jump down to section 3, let's go into I'm gonna go to the lecture deck first, and I'm just gonna show you that I'll quickly swing through this. Just to recap, we created the database, and we did it from the command line. You could just as easily do it from the SQL editor here if you cut and pasted the code. That takes a little longer, but it's certainly available for you to do that. We created the DDL. We want to make sure you understand that SingleStore has a very extensible stored procedure language. You know, user-defined functions, stored procedures, user-defined aggregates, arrays, records, control structures. You can use all this advanced math to complement the ANSI SQL compliant engine. And then we have an example here for you of that stored procedure that we just built. I just showed you what code to run. Shay took us through step 2. I'll swing through that real fast. And we're basically being able to consume driver and trip data. That's coming off of PubSub down through data flow into cloud storage. Our neighborhoods file, as a recap, came out of cloud storage. It was a polygon. Now, we've got everything in cloud storage. We wanted to show you about step 3 with SingleStore pipelines. We're going to be able to consume from a number of different sources, and one of them being Google Cloud Storage. What you're going to need to do, and I'll show you this in these Cloud Shell, but for each pipeline, and there's 3 of them, you need to actually go in, because you've created a bucket in step 2, you need to go in and edit the create pipeline command for drivers and trips and neighborhoods. Now, just like you can create a database or a table in SingleStore, we have pipelines which are first-class citizens in the database. And what we're doing is we're putting the bucket and the next level inside the bucket, drivers. So there's a lot of files that are getting pumped in there, even the trips. And so this pipeline will consume, as soon as a new file comes in to that bucket and directory, it will actually consume that. You have to add your credentials. So all you have to edit is your bucket and your access ID and your secret key. And again, it's for 3 of the pipelines. So if I wanted to just show you that real quick in the Cloud Shell, I'll quit the CLI for a second, and I'll show you, I need to get into the correct directory. So we've got all those commands in your, for you to easily move in here. But I'll just show you one of the pipelines, and then you can work on all 3. So if I show you, if I do VI on, actually it's one DML, data manipulation language command. So it's create New York City pipeline. So if I VI that and I go in here, I need to come down here and I need to edit just the bucket. So you need to change put your bucket in here. So you would remove that text with the bracket, with the arrow, right arrow, left arrow, and you would add, you could do an I. So you can say my bucket. It's something like that. So whatever you called your bucket, and then you need to do the same for your access ID and your secret key, but you need to do it for the pipeline consuming the driver data, the pipeline consuming the trips data, and also the pipeline consuming the neighborhood data, a set of polygons. Now, if you want to, and you're not comfortable with VI, you can certainly go into section B in your GitHub, and you could go down to the pipelines, and you could go hit the raw button. You could copy and paste this into the SQL editor if you'd like, and you could just edit it there and run it from there. There are two ways to submit it. And so I'm suggesting that if you wanted to, you could go into the SQL editor here. And if you're not familiar with VI, you can just edit it that way and run it directly from the SQL editor on your portal. That is an option. I wanted to show you that as an option. So let's go back and see what we're asking you to do. We're asking you to edit the create pipelines script, and then we're asking you, after you edit all three, then what we're going to do is we're going to create, so we're editing it through VI and or through the SQL editor in the portal. Then we need to, if you run it over there, you don't have to create it. Here, we're going to source it from the command line. So that would create the pipelines. You could show pipelines to see that they're created, but they won't be started. Then you can start the pipelines by just copying this command and running it through the MySQL command line, and you can show the pipelines. We've provided more information in here about pipelines. We've also provided all the ways so you can look at the tables as the data is coming in and being consumed. And we've got a number of queries that we've also put in here, like total number of trips for each neighborhood, etc. And these are also in the stored procedure, just so you know. So you've got a lot of queries you could run in the homework section, I would say, over time when you get to that. And to get the real-time stored procedure running, you'll want to open up a separate Cloud Shell tab, and you'll want to just go in and start that stored procedure. So all of it's here for you to run. And now what I'd like to do is I'd like to turn it over to Bruce and allow him to take us through the dashboarding with Looker and all the BI visualization. So Bruce, let's go ahead and turn it over to you so you can help the students take us home here with the remainder of this session.
Thanks, Mark. Let me go ahead and get my screen sharing set up here and we'll get going. All right, I think everybody should be able to see my screen now.
I can see it, Bruce.
Excellent. All right, well, hello, everybody. For those of you that weren't here before when I introduced myself, my name is Bruce Sandell, and I'm a senior sales engineer with Looker's Alliances team. I support all of our technology partners, such as SingleStore. I've been working with the SingleStore team for a little over 4 years. And over the next 40 minutes or so, I'm going to give you a brief overview of Looker, go through the high-level agenda of what we'll be covering in the All Hands Lab, and then we'll get to work building out a dashboard. So organizations that work with Looker find three primary benefits. The first is that it makes your data teams more agile. Looker is a single simplified system that results in a faster response to change. Data teams can create automated, repeatable processes, allowing them to focus on new initiatives faster. Second, data teams are more efficient. Analysts save time by providing self-service experiences for users and are able to collaborate easily with other analysts. Their focus can change from maintenance to improving business outcomes. They shift from managing infrastructure to delivering insights. And finally, governance and control of data is simplified when the systems are centralized. There's a single source of truth for metrics, data remains in a single repository, and rapid access to data and agility aren't sacrificed with this improved governance. At its core, Looker is a fundamentally different way to do analytics, and that's based on a few key areas where Looker has focused our technology. First, Looker has an in-database architecture. This means that no data needs to be extracted or moved from the database or warehouse before analysis. Looker supports more than 50 unique database dialects, so whichever database you choose, Looker can leverage it. And Looker can take advantage of native database functionality, such as machine learning tools, data permissions, and any other advanced functionality that your database provides. We'll take advantage of some of SingleStore's advanced functionality in our exercises today. Second, Looker's powerful semantic modeling layer, also known as LookML, saves analysts time. Analysts model data and define metrics in a single unified way to keep the whole organization in sync. And developing models, metrics, and new ways to use data is highly collaborative. It reduces unnecessary repetition of work, and it's Git integrated. Model changes can be controlled, audited, and distributed among departments and analysts. Third, Looker is cloud native and extendable. It's fully web-based. With Looker, you get full API support, so you can connect to third-party systems or even do analytics with other tools if necessary. And Looker can be deployed on the cloud infrastructure of your choice, and we support on-prem installation as well. Looker is open and interoperable, and that's a core architectural tenet. Here's a high-level overview of Looker's architecture. Looker will work with you to centralize all of the data sources that are important to the business across sources like SaaS applications and transactional data and get those into a centralized data warehouse. Looker then connects to that centralized source of data, which is where you're going to define all of your business logic. Then you can use Looker to accomplish all of your data-related tasks, which we bucket into four main categories. The first is modern BI. That's creating dashboards, reporting, and ad hoc exploration for all of your internal analytics needs. Next is integrated insights. And that's bringing the data from Looker into the tools that people are already using, like CRM, customer support, and chat applications. Next is data-driven workflows, and this involves sending data to third-party tools to automate workflows, like sending an audience from Looker to a marketing automation tool or a curated set of machine learning data to a machine learning tool for doing predictive analytics. And finally, completely custom applications. Using the data from Looker to power your own analytics experience, either through embedding Looker visualizations directly or leveraging our API to power your own completely custom data applications. So why do Looker and SingleStore work so well together? Looker's in-database architectures allows companies to maximize their investment in SingleStore by taking advantage of SingleStore's speed and innovative features. We really see SingleStore shine in streaming use cases when access to near real-time data is critical. Looker makes self-service reporting easy for end users. And with the data coming from a single source of truth and users sharing common definitions of business metrics, your data analysts are freed from being full-time report writers and can spend their time on more innovative work. Finally, Looker allows users to take advantage of all of SingleStore's advanced functionality. In our exercises today, we'll be making extensive use of SingleStore's geospatial functionality. Here's a high-level agenda of what we'll be covering when we go through our lab today. First, we're going to take a look at the anatomy of a Looker project. Then we're going to create a connection from Looker to SingleStore, generate a default LookML model. Then we'll enhance the model file and add some business-specific dimensions and measures. And then we'll create a visualization, save it to a dashboard, and customize some dashboard properties. And I think that should pretty much take us to the end of our time. So here's a look at the dashboard that we'll be creating together. And then finally, before we get started, this diagram just shows you how all the parts of a LookML project are interconnected. We're not going to spend much time on it now, but it's here for your reference if you need to go back and take a look at it as we go through our exercises today. So the rest of what we're going to be covering today is from the student guide. So hopefully all of you have your student guides open, and we'll be on step 4, which is bringing it all together with visualizations. So if you can get into that section, and probably task number 1 is going to be the hardest, that's logging into Looker. So Mark had provided you with a link to a document that has Looker usernames and passwords that you can use for accessing the Looker instance. So if everybody can make sure that you have a Looker username and password and go ahead and get logged in, we'll all be sharing this same instance of Looker. It's called memsqlhandsonlab.looker.com, and you'll connect using the username and password that you get from the sheet. And make sure your username includes the plus sign. So it's going to be Looker Lab memsql plus your lab number, and that plus sign is actually in the email address at gmail.com. And then the password is the number 4 analytics _ your lab user number. So 4 analytics _ 1 or 4 analytics _ 10. So everybody take a second to get logged in, and then we'll get started on a couple administrative functions, which you won't be able to do today, but I'll walk you through them and show you how they work. And then we'll move on to the activities that you'll be able to participate in. So I'll give everybody a minute to get themselves logged in. All right, hopefully everybody's logged in now. So the first thing that you need to do to be able to work with a new data source in Looker is to create a connection for it. And you'll see that I have access to Looker's admin functionality, which you won't have today. So I'm just going to walk you through this step. So we'll go into the admin menu and we'll go to connections. And this is where we'll see all of our existing connections. And if we want to add a new connection, which we do, we'll hit the Add Connection button here. And this will take us into Looker's new connection screen. So the first thing we'll do is give our new connection a name so that we can easily refer to it in the drop-down list. And then we'll pick the database that we want to connect to. Looker supports over 50 different unique data stores. Pretty much anything that supports a SQL interface we can connect to. So we are going to connect to memsql 7 plus, and we should have this menu updated to SingleStore rather than memsql in the next release. The next thing that we need to do is supply the name of the host that we want to connect to. and the name of the database, which I believe is NYC_taxi. And provide our username and our password. And if I hadn't made any typos, we should be able to go down here and hit test connection. And that's really all that you need to do to create a new connection. So you can see that we're able to successfully connect. I'm not going to save this connection because I already have one created that we're going to be using for the lab today. So let's move on to step number 3, which is creating a Looker project. A project is just a collection of the files that describe the objects, connections, and user interface elements that will be used to carry out the SQL queries for your Looker users. You won't have permissions to create a new project, so I'm just going to demonstrate how you would create a new LookML project. So we go into the develop menu and we go into development mode. You have to be in development mode to make any LookML related changes. So this is typically functions that's used for your database, your data admins, the people that are going to be doing the development and maintenance of your LookML models. So I'm going to select Manage LookML Projects. I'm going to create a new LookML project and call it Dev Days. And then we have a few starting points when we create a new LookML project. We can either generate a model from a database schema, and that's what we'll be doing today. If you just had a file of SQL statements, you could use that as well. If you had an existing LookML file in our project in a GitHub repository, you could select that, or you can start from a completely blank project. So what we want to do is select the connection that we want to work with. This is the DevDays lab connection that's already configured for you. And then we can either specify schemas that we want to extract the metadata from, or we can use the default one that's configured on this connection, which is the New York City taxi cab database. So we'll go with the default. And when I hit create project, Looker is going to generate a new LookML model for us by going through and examining information about all of the tables that are included in the schema and inferring join relationships between those tables. So let's go ahead and hit create project. And we can see that Looker's generated the preliminary model for us. So this model, it contains a bunch of additional tables that we're not going to be using for our lab today. These are the tables that you would create as you went through the SingleStore steps of building out the stored procedure, and these are some of the tables that go along with the stored procedure. So I am now going to switch from this model that we generated, and I'm going to go into model that you have access to. Hang on one second. Get logged back in here. And that is this DevDays taxi basic model. This is the model that we're going to be working with today. So let's just take a quick look at what a LookML file consists of, or a LookML project. So there's two main types of files. The first one is called a model file, and that's the one that we're looking at here. And the model file describes all of the tables that we're going to be working with and the relationships between those tables. So Looker is going to attempt to infer what the join relationships are, but you can also go in and modify these join relationships however you want. Another important thing to notice here is that Looker is going to break the tables into what are called explorers. And explorers are really just logical groupings of tables, so that when your end user goes in to do their own reporting, rather than present them with a list of 100 tables that they need to go through and figure out what it is they need. The data analyst breaks the data down into sort of bite-sized chunks for the data, just business-specific groupings of data for answering specific business questions. That way, when the end user is ready to go in and do their own self-service reporting, they'll go under the Explore menu in Looker, and they'll see all of the options that you have available for them. So today, we're going to be working primarily with this Trips Explore in the Dev Days Taxi Basic model. The second type of file is what's called a view file. Looker is going to create a view file for each table that was in the schema, and it will create a dimension for each column in the table and add an additional measure of account, which will be used for groupings. All right, so the next step is that we need to go into development mode because we're going to do some enhancements of the model file. And these steps that we're going to do are all pretty quick. So if you want to just follow along with me, go into development mode, and then we can start making some changes to the model, and you can all do them at the same time that I'm doing them. And that's because Looker is, this model is integrated with a GitHub repository. So when you go into development mode, you're going to be working with your own private branch so that none of the work that you do will interfere with any of the work that anyone else is doing. So I'm going to go into my model file, this Dev Days Taxi Basic model file, and I'm going to enhance this model file by linking to the neighborhoods table. And Mark had described the neighborhoods table earlier. It describes all the neighborhoods in New York City, what boroughs they're in, and it also contains an array with polygon information, which describes the shape of that neighborhood or borough. So I'm going to add in some information here about those neighborhoods so that we can do some reporting on them. So you can just copy and paste this whole section, this Trips Explore from the user's guide. And if you're in development mode, you should just be able to replace the current Explore Trips section with this new section. And if we take a look at what we just added, we added 2 additional joins. Both of the joins are to the neighborhoods table. One of them we've aliased pickup neighborhoods. The other one we've aliased drop-off neighborhoods. And if you're familiar with writing SQL, you know that you would alias the table by using the as clause. And later we'll take a look at the SQL that Looker is going to generate, and you'll see how it's translated this pickup neighborhoods and drop-off neighborhoods into alias table names. And we're using single source specific syntax for the join condition. So each of the trips has a pickup location and a drop-off location. And those are latitude and longitude points. And using this geography intersects function, you can figure out what neighborhood that latitude and longitude point intersects with based on the polygon data for the shape of the neighborhood. So once you've added that in, go ahead and hit Save Changes at the top. And the next thing that we're going to do is we're going to enhance one of the view files. So if you expand the Views section and click on the driver's view, as you're working with this data and creating reports, one of the things that you may want to do is rather than having one column for the driver's first name and another column for the driver's last name, which is the way the data is stored in the table, you may just want to display it in a more natural form like last name, comma, first name. So let's go ahead and add in a new dimension to this view file that we'll call full name. And again, you can just copy that full name dimension and paste it in here. So I'm going to paste this into my drivers view file and then go ahead and save our changes. And if we look at what we just added here, we've added a new dimension called full name. Its type is string. And then again, we're using SingleStore specific syntax. So we're using the concat function to add the last name with a comma and a space and the first name. One really important thing to take note of here is the Looker's $ curly braces notation. This is the Looker substitution parameter, and it's really a key feature in LookML that allows you to only have to make changes in one place. So everywhere that you use the substitution parameter, Looker is going to go back and get the original definition of that for you. So if we were, let's say that we had used this $ curly braces last name notation in 20 different places. Everywhere that you use it, it's going to go back to the original definition of the last name field, which you see here. So if at some point we were to change the definition of the last name field, like let's say that we always wanted to put the last name in init caps, and we change the definition of here to say init caps last name, then everywhere that we had used this $ curly braces notation to reference the last name would automatically inherit that change. So any report, any dashboard would automatically be updated with that. So no more digging through different reports and SQL statements to see all the places that you've used it, so that you can update it so that everything will stay in sync. Use the $ curly braces substitution operator, and then you'll only have to do that in one place. So hopefully everybody has got the changes to the model file and the change to the drivers, the view file for the drivers. So the next thing that we're going to do is go into Looker's Explore interface. And for people that are going to be doing their own self-service reporting or data exploration, this is where they're going to spend most of their time. And they'll be taking advantage of all of the work that you've done in the LookML model. So if you go under the Explore section, go down to the section that says Dev Days Taxi Basic, and then click on the Trips Explorer. This is going to take us into the Looker's Explore interface. And so what you have over on the left is called the Field Picker. This is where you're going to select all of the fields that you want to work with as an end user for doing your reporting. And this is also where you're going to, all the work that you do as the data analyst, updating the LookML file to include all your business specific metrics is going to be exposed to your end users here. And we can see right here some of the changes that we've made to our LookML file already. So in our drivers table, we can see that we now have a full name field that we had added. And we can also see that we have these two tables, drop-off neighborhood and pickup neighborhood, that we had added before as well. So let's go ahead and create our first query. So in the drivers of the, let's just go ahead and click on full name. So if you want to add a field to the report palette, all you have to do is click on it, and then you'll see it appear over here on the right side. If you click something by accident, you can just click on it a second time to remove it from the palette. And then we're going to go under the trips, and we're going to add a count. So the report that we're going to create here is going to be a list of the drivers that make the most frequent trips between boroughs. So we want a driver, we're going to pick drivers that start their trips in Manhattan and end their trips in another borough. So the next thing that we're going to do is add a couple of filters to this report. So if we expand our drop-off neighborhoods and our pickup neighborhoods, we want to filter on borough. And in order to filter, all we have to do is hover over the name of the field we're interested in. And then we're going to click on this little upside down triangle icon. And that's going to add it to our filters. And we want to filter on pickup neighborhood is Manhattan. And if you just click into the field, it's going to give you suggestions of all of the valid fields that are there. And it's doing a real-time query on the data to get that. So you can see, how quickly it can query that data in SingleStore to get that list for you. The next thing that we want to do is pick a drop-off neighborhood. So we're going to go to borough and filter again. And this time we want boroughs where the neighborhood is not equal to Manhattan. So in the drop down here of all of our different comparative selections, you should select is not equal to, and then again in the drop down, pick Manhattan. If you accidentally clicked on one of the borough names and added it to your report, remember you can just click on it a second time to remove it from the report, or you can click on this gear icon and select remove. So you should only have two fields, driver's full name and trips count. So before we run this, let's click on the SQL tab and see behind the scenes all of the SQL that Looker is generating on your behalf to send to SingleStore. So if we click on the SQL, we can see that Looker is generating a SQL statement for us as we're adding fields and filters. And along with that, you can see the effect of all the changes that we made in the lookml file. So here where we've selected driver's full name, you can see that Looker has just substituted in exactly the SQL syntax that we had specified for how to create the driver's full name. And then in the join section down here, you can see that New York City, the neighborhoods table is joined twice. And each time it's aliased using the alias name that we had provided, pickup neighborhoods and drop-off neighborhoods, and also using all the geospatial functionality that we had specified as the join condition. So typically end users won't have access to this SQL tab. It's generally just for developers, but we wanted to include it today just so you can see what Looker is doing behind the scenes. So let's click on our results tab again and go ahead and click run. And now we should see the results of our query. And then if you go ahead and expand the visualization section, just by clicking on the arrow, you can see that we have a lot of results here, more than is really particularly useful for working with this data. So I'm going to go ahead and refine this even further. And I'm going to change my row limit to 15. So we have an easier set of data to work with. And then I'm just going to go ahead and hit return and rerun this. And let me shrink this so we get a better look at this. So now we can see that we have a report that shows the top 15 drivers based on the number of trips that have started trips in Manhattan and ended trips in other boroughs. So let's go ahead and see a few of the other visualization types that Looker has available. By default, Looker is going to pick the best of visualization type for the data that you have selected, but there's many other types as well. There's table visualization, column chart that we saw before, a bar chart, got scatter plot, line chart, area chart, pie chart, we have maps, we have single value visualizations. There's a number of other visualization options available under these ellipses as well. And if you still don't see what you need, up here in the top right, this icon is the Looker Marketplace. And you can go in the Looker Marketplace, and there's a number of other visualization types that you can include as well. So let's go ahead and make a couple customizations to this visualization just to make it a little easier for our end users to work with. So if you click this gear icon right next to where it says edit, this is going to give you all of the customization options that are available. And depending on which visualization type that you've selected, your customization options are going to be a little bit different. So I'm going to go into the series section, and I'm going to pick a color collection that I like a little better. Looker comes with a bunch of different default color collections, and you can also add your own custom color collections that have your company's default colors. So I'm going to pick Dalton, which I like a little bit better. And then I'm going to add value labels to make it a little more clear what each of these bars in the chart represent. So I'm going to click on the value section, and you're all welcome to do this right along with me. And I'm going to click value labels, and you'll see that now we've added these numbers to the top of our chart. And then I'm going to go ahead and just click the gear icon again to hide this. I'm going to hide our filters so we can get a better look at our new visualization. So I am happy with this visualization. This is exactly what I wanted. And so there's a number of things that we can do now that we've got this visualization created. So if you click on the gear icon up here next to the Run menu, you can see the list of all of the different things that we're able to do with this visualization. The first thing is that we can save it as a look, and that's Looker terminology for a standalone report. Next, we could save it to a newer existing dashboard. We could download this data or visualization. If we wanted to just send this off as a one-time to a colleague and have them take a look at it, we can do that as well. We could click the share button and add other users to this report. As you're working through visualizations in LookML, every change that you make is reflected in the URL. So you can actually take the URL, copy and paste it, send it to a coworker, and they can get into the exact visualization that you're working with. So today we're going to save this to a dashboard. So I'm going to click Save to Dashboard. And we want to make sure that we're saving this dashboard into our personal area. So you can see over here on the left, there's a list of areas where you can save this. So the shared area is where if you want to create something that's going to be shared with other users of your Looker instance, so with your coworkers, you would save it in your shared area. If you wanted to create it and have it for your own personal use, or if it's still a work in process, you want to click on your name or your Dev Days lab name, which is what you're going to see over here. And that's where we're going to want to save that. So go ahead and select your own personal area here. And then we need to give this, this visualization a name. So I'm going to call this Crosstown Traffic, Top 15 Drivers. And I want to save this to a new dashboard. So I'm going to click New Dashboard and give this a name, and I'm going to call this My Dev Days Dashboard. You can call yours whatever you'd like. Click OK, and then click Save to Dashboard. All right, so now that you've saved your dashboard, there's a couple of different ways that you can access that dashboard. The first is just to click on the hyperlink at the top after you've saved it. Or in the future, when you want to access it, if you go under the Browse menu, the Browse menu is where you're going to come to find all existing content that's available to you, whether it was created by you or created by others and put in the shared folders. So navigate to your personal folder, and you should see your Dev Days dashboard in there. So let's go ahead and click on that to open it. And we can see our new dashboard is here. And so I want to show you how to make some changes to your dashboard so that you're able to customize it, especially as you add new tiles. So if you click on these 3 ellipses in the top right corner and go to Edit Dashboard, this is going to put you in edit mode. So a few of the things that you'll use a lot when you're in edit mode, in the bottom right corner is the resize handle. So I'm going to make this tile a little bigger just by dragging it to the size that I want. And then in the top left corner is where you'll find the move handle. So as you're building out your dashboard, if you want to reorder the tiles, you just grab by the move tile, move them to wherever you want. And then when you're all done, make sure you click the save button to save your changes to the dashboard. So that's all we're going to do for dashboard creation today, but I want to give you a few tips and tricks so that you can go ahead and build out the rest of this dashboard on your own. So the first thing is, if you look in your users or in the students guide, you'll see that we will be using recipe cards for building out the rest of the tiles. And if you take a look at the recipe tile that is included as part of task number 9 at the very end where you're creating the query, you'll see all of the elements that we use for creating this dashboard tile. So we've created, it shows you where the title is, what the model name is from the Explorer, which Explorer to use, which dimensions and measures to use, which visualization type, which filters, and then the visualization edits that we've made. So as you move through the student guide, you'll see at the end that there's a list of several more of these recipe cards that you can use to build out more tiles. And also on step number 14, there is a big block of additional LookML that you can paste into the trips view file. And you'll see a lot of that is similar to what you had done in your MemSQL, or sorry, in your SingleStore steps before, when you had created your stored procedure, generated some tables to show you things like, the average trip distance and things like that. You'll see how those are created using LookML. So just copy and paste those in, go through the rest of the recipe cards that you'll find at the end. And those will be in step number 15. So you can go through, complete all of those. And if you get stuck, if you go to the Browse section, go into the shared folders, you will see that there's this dashboard already built here called Taxi Activity. So if you're having trouble building any of the dashboard tiles, all you need to do is go into this dashboard, pick whichever tile it is you're having trouble with, go up to the top right corner, click on these 3 ellipses and go into Explore from here. This is going to take you into the Explore section that we were just working with. And from there, you'll be able to see exactly how this dashboard tile was created. So for example, for this one, we're using a single value visualization. We only have one measure, which is the trips count. And then you can look at the edit section, see any edits that were made to the visualization's appearance, any row limits that were applied here. So that'll be just an easy way for you to go and check your work as you're going along. So we're just about at the end of our time. So I am going to turn this over. I'm going to turn this back to Mark so that we still have a few minutes left for addressing questions.
Hey, Bruce, thank you so much. We really appreciate you taking the time to be with us today and going through your section. And I really hope the students found it valuable. I certainly did. I learned something every time I get to work with you. So thank you so much, Bruce. Folks, we've gone through, here, let me show you on the agenda real quick, just to recap. We've gone through, let's see here. We've gone through the build steps, 1, 2, 3, 4. So really, we just have a cleanup. Whoops, I'm sorry, I didn't mean to go backwards. We just have a cleanup step to take a look at in the student guide. So if I switch over real quick to the student guide, you know, one of the things that we want you to make, you know, if you've got pipelines running, you'll want to go ahead and stop the pipelines using this command from your Cloud Shell, actually within the MySQL client. So you'll want to do that. And then you could go ahead and go into the Cloud Shell that's running. I think you set up a second Cloud Shell to run your stored procedure. It's just a basic demo stored procedure, so it's looping. So if you just Control-C out of that, get back to the command line, you'll be fine there. And we don't have any looker services to clean up. Shay, I'm not sure if you were able to hang out with us. Are there any services that you want to talk to them about on Google that they want to keep an eye on, as far as when they're all said and done, they can shut them down, or are we good there?
Yeah,
On
I
the
mean, mostly it's the data flow jobs. Make sure those are stopped, right? And if you have files in cloud storage, those will be charged too, but at a much lower rate. So you'll just want to delete them as well. I mean, the easiest way is just to shut down the project. Obviously, you'll have access to the lab guide if you want to do this again, but to make sure you don't incur any costs, I'll go over the $50 credits that you got from the process here for Google Cloud. Make sure those data flow services and jobs are shut down when you're done with this.
Okay, that's cool. And so Bruce and Shay, thank you so much. We're approaching that top of, you know, we're right near the end of the session. I just want all the students to know that you will get a survey emailed to you, and we would really, really appreciate feedback so we can help improve our workshops. So please do that. And you know, if you guys in the deck there, you have our emails. You know, we're all close partners here. If you need to get a hold of anything around with Looker, just reach out to Bruce. And obviously with Google Cloud, Shay is your contact, and I can be the SingleStore contact. But we'd like to dive in if you've got a real challenge on your hands with a customer or a new opportunity. We'd love to hear from you. With that said, we're done for the day. Thank you so much. I'll turn it back to our moderator.
Mark, one more thing. I know that you had said this earlier, but I just wanted to reiterate to people that if you do want to go through and finish building out the dashboard, that this Looker instance will be available for you for a whole week to work with.
That's a great point, Bruce, and we'll keep the classroom SingleStore cluster up and running under it for a full week, right, Bruce? Is that what we're going to do?
Exactly.
Okay, wonderful. And folks, enjoy your credits. Enjoy doing finishing up if you'd like to do that, and look for the feedback from you. And back to Diego.
I want to thank Bruce, Mark, and Shay for the presentation. We will send you a follow-up email with today's recording. Please make sure to answer the survey after the webinar ends and check out our other virtual events at singlestar.com/events. Thank you for joining us and have a great rest of the day.